Hello, it's Mr. Thompson here, bringing the answers to vector questions I set you last week. You will remember the worksheet that I sent you had 10 vector questions, and at the top of the worksheet give you a method using scale diagrams of how to calculate the resultant forces. I'm going to show you that one or two of the solutions and also a slightly different method too. So the first question, quite straightforward. Does this one need a scale diagram? You all spotted this, I think, that the two forces, vertical forces, are equal and opposite and therefore cancel each other out, and therefore you're left with a resultant force of 6 newtons to the left. Quite straightforward. Bit more of a challenge now. We've got two forces which are at right angles to each other, and you can use two methods. The first method is a scale diagram. So to do this one, you need to work out scale. For example, 1 centimeter for every newton, and therefore be 9 centimeters to the right and 3 newtons down. Complete the triangle to get a resultant force shown in blue here, and then because the scale diagram, you can measure that with a ruler. That should come out as 9.5 centimeters. Measure the angle with a protractor and you get your resultant force of 9.5 centimeters, which means it's 9.5 newtons on this scale, and at an angle of 18 degrees from the horizontal. The second method for this question could be, because the right angle triangle, using Pythagoras theory, and you have the triangle again, it's a right angle triangle, and therefore you can use Pythagoras theory. So 3 squared plus 9 squared equals to the resultant squared. So the resultant squared is 90, because 81 plus 9 is 90. Square root of that is 9.5 newtons. The angle could be worked out by sine, cosine, or tan. So I'm just going to choose the tan. Tan would be opposite of adjacent, and therefore the inverse tan is 3 over 9, or 0.33. And if you put on your calculator, the angle works out as 18 degrees. Obviously the same answer as the other method. You can choose which one you prefer. For this question, combining, there's 3 forces here, combine 2 of them are in the same plane, the 9 and the 6. Take the 6 away from the 9 and you're left with 3 newtons to the right. You've also got 3 newtons down. Draw your triangle. Either method, scale diagram or Pythagoras, will give you an answer of 4.2 newtons at an angle of 45 degrees to the horizontal. And this one, pretty much the same method. You can take the 3 away from the 8 to get 5 to the right, and you can then draw in your triangle and you can work it out as 5.4 newtons at an angle of 21.8 degrees to the horizontal. Again, either by Pythagoras or by a scale diagram. It could ask you in the exam to do either. It might specify what you need to do, so you do need to know how to do both. Finally, slightly different one. If they're not at 90 degrees, how do you do it? Well, I'll give you the hint on the worksheet. You need to use a parallelogram of forces instead. So to do that, you draw your parallelogram. You draw 6 newton sides going up and 8 newtons on the horizontal, and you draw on your resultant force. So you need to use a scale diagram. So if it was 1 centimeter for every newton, you measured the resultant force, it should come out at 12 newtons. And then you use your protractor to measure the angle, and the angle should be 36 degrees to the horizontal. Hope this helped to clear up any problems that you had. I hope you enjoyed the video, and thanks for listening.